Hi everyone, this is Nate with KeySoft. Today we are going to look at an introduction to surface modeling. Surface modeling is a fairly new module in the KeySCAPE scope of things. We brought this over from LandCAD when we acquired that, and we have since been updating it and integrating it into the KeySCAPE interface. It's a great tool. It enables you to have a lot of the capabilities found within, say, Civil 3D from Autodesk, but in our case it's not as complicated as that. It doesn't cover topics like utilities, sanitary sewers. It doesn't do like giant road alignments, like giant infrastructure projects. It really focuses on site-specific needs of landscape architects. So it's a much more streamlined and intuitive approach to looking at a site than just using Civil 3D. So we need a starting point. That means we need existing information from a surveyor, from a civil engineer, from a drone that's snapping spot elevations, a LiDAR file. There's a number of ways to get data into KeySCAPE. It could be a CAD file, it could be a text-based point file, it could be a land XML file coming over from Civil 3D as well. But really that's a lot of details. It's pretty complicated. Today I'm going to be looking at a workflow that just uses some existing contours, and we're going to build a surface model, and then we're going to analyze that surface model. In a future webinar, we'll look at creating proposed conditions. That gets a little bit more in-depth and a little bit more time-consuming, but way faster than grading by hand and revising grading by hand. But we'll focus on that in a future, more advanced webinar. So let's look at the interface. We have the good old KeySCAPE series of ribbons here, starting with core. Surface modeling is where we're going to focus today, and maybe a little bit on site analysis. So let's look at the base data I've brought in so far from our surveyor. We have polylines that are joined together to create contours. If we click on one, we can see that it's continuous. There's no major gaps. If there were gaps, we can address those as well, but let's just focus here on what we have on screen. Let's look at the properties. So I'm going to go to the AutoCAD Properties menu. And if I select one of these, we can see that, yes, it's a polyline and it has an elevation assigned to it. Now this is critical because without elevation, we don't know how to build a model. Again, if you're lacking that information, we can help there as well. So let's go back to surface modeling. And let's just create the existing condition. First thing I do is over here on the Prepare ribbon area. I'm going to click on Surface Models, and this gives me a list of the surface models that are within this drawing. So I've already created one for demonstration purposes, but I can, let's create a new one and just duplicate that work so we can see the workflow. I'm going to call it Existing 2. And then there's some settings here we can look at as well. So the valid minimum, valid maximum, these are good to narrow down. If you kind of know the range of what your site might be, you can use this. So I know that I don't think there's anything less than, say, 500 feet in this drawing, and there's nothing more than like 2,000. What this does is eliminates you from inadvertently selecting something that's at 0 elevation and creating a giant hole in your model where it tries to connect the lines between something at, say, 900 feet elevation and 0 feet elevation. There's some other options here. We want faces for our triangulated surface, curved break lines. This is just how it treats curves, it interpolates points on curves, and these can be adjusted based on the size, but usually the default's fine. Contours, these are just preset settings for when we do generate contours. We know what index we want. These can always be adjusted later though. And a few other things for creating grids, which is another type of surface, but really all the defaults are fine. Let's just focus here on the name and getting the valid maximum, valid minimum somewhat reasonable. Let's click OK. And now we have a new surface model. It's empty right now. If I click on the Properties button, we can see that none of the information is available. If I click on the one that was already made, you can see we have a number of points that it used, a minimum elevation, a maximum elevation, and some other info here. So let's hit close. And now let's build the model. So like I said, I already had contours in the drawing. If I needed to manipulate contours, there's this pull-down menu here under Construct. There's tools to digitize contours. So if I wanted to, say, trace a scan that I already had, I could do this, do a sketch, pick a starting elevation, and pick our contour interval. And then as I draw, it's going to automatically increment to that next elevation when I complete the contour. So it's a way to quickly sketch from scratch a contour. There's also join. This is if you have some holes in your contours, it's going to connect the dots. Same thing with join broken contours. So you can set a tolerance. If it finds a gap under that tolerance, it's going to try to connect the lines there. So again, helping you deal with bad data. Hopefully you don't have to, but there's a few tools here as well. If you do have the contours in, but they're all on 0 elevation, you can do a change contour elevation. Type in, say, the bottom of the hill is like 950 and the increment is 1. You can click apply and then create a crossing line that's going to then start at the bottom and assign elevation to all of those lines one at a time at a 1 foot interval. So again, there's some shortcuts there, but we have some good data, so let's use that. Here under Triangulate is where we start building out the surface, adding information that is going to be included in that surface. A few options here. Surface models, that's great if you have point data or a mixture of points and contours. Surface model from contours uses a slightly different algorithm if you're dealing with just contours like we are today. And then surface model from sparse data, again, that's if you have a mixture like profiles and spots and a bunch of other shapes, but we can get into that in a more advanced webinar. But let's use surface model from contours for this example. So it looks like I have a command running still. Let me close that. There we go. Surface model from contours. It's going to be existing 2. Boundary. If you don't have a boundary, what it's going to do is connect vertices between points. So let me close this real quick. Let's zoom into this part of the site. So we have contours here that kind of wrap around this corner. If we don't give it a boundary, it's going to try to connect vertices across that corner. And it's going to make some assumptions. It won't necessarily be bad because it's off-site, but we really don't want it to do that. So what we did is drew a boundary line around the extents of the contours to trim that off really cleanly so that we can get this roadway included, and it's not going to draw a bunch of big connecting vertices like that. All right, so back to Triangulate surface model from contours. So I'm doing existing 2. Boundary, I'm going to select it on screen. Void regions, that's if you have islands you want to ignore, but we don't have any here. a few check marks here at the bottom. Display model, what that does is creates a preview of the triangulated surface once it's done calculating. It doesn't actually draw any geometry in the model, but it does give you a preview. So it could be good if you don't want that triangulated surface in the drawing yet. You might check that just to check that everything's good. I'm gonna leave it off for now. External points file, that's if you have a text-based point file, you can include that here. Display details, we're going to ignore that for now. That's more an advanced setting. We are going to place triangles, so that's going to actually put the geometry of that surface in the drawing. And let's look at the settings here before we continue. So here we have the maximum and minimum. These are things we set before. So you can set them at the beginning, you can set them now. It doesn't really matter. What is important is this little button here. And this is where we tell it what layer to place objects on. So we're creating a triangulated surface now. By default, it wants to call it that. Let's call it 10 existing 2. And let's pick a color to make it easy on the eyes. Kind of a darker green maybe, something like that. Okay, so I click apply and we follow the prompts on the command line. So we want to select objects first. So I'm going to zoom out and I'm going to grab all of my contours. Now I can go ahead and grab things like the boundary and this property line because they're on 0 layer. Sorry, not 0 layer, they're on 0 elevation. So because we set that range, it's going to ignore those objects anyway. So I don't have to be too picky about what I grab. Now you may want to freeze off stuff. You need to do some layer management here to make sure that you don't have some stray lines or stray points that you don't realize are in there that are going to affect the output. So let's hit enter. And the second prompt, because I told it that I wanted to select a boundary, I'm prompted to now grab that. Crossing break lines found. So what that means is that there are some errors in my contours. So I have a contour crossing another contour. We can continue now and just accept that there's going to be a small error somewhere. We could also hit no and try to track that down. But let's hit yes for now. We'll track it down later. This can be an issue, especially on a proposed surface when you're trying to get that accurate. But we'll go back and fix that in a bit. So now we can see that we're drawing 32,000 objects. These are all the triangles that will make up the surface. We'll hit close. And let's zoom out to see what we have. So you can see here, this is probably where the error is, somewhere in here, because it created a few triangles outside of the boundary. But that's okay, we can track that down, or we can just delete them out manually. So we have this spider web of triangles. Let's turn on a shading visualization. If you go up here to the upper left-hand corner, you can choose some things like default views and then visualization styles. Let's click on shaded just so we can see what this surface looks like. So it fills in all the triangles, it adds some shadow lines and stuff. So we can see we have the valley here where this stream corridor goes through. We have kind of some errors up here. That's probably that break line. Great, so we know it's fairly accurate. That's what we want. Let's go back to wireframe to speed the drawing back up again. So we have a surface to build on. If we want to, let's go ahead and turn off the triangulation though and see what we can do with it being hidden. It doesn't need to be in the drawing as triangles necessarily. That's just a way to visualize it. If I had clicked here to not to place triangles, we would still get a surface it just wouldn't be visualized. It'd still be in the drawing, but invisible. That's great for keeping your file size small if you need to transmit the file. But also, even if it's invisible, we can still place spot elevations and figure out and do some analysis on this surface. So let's place some spot elevation labels. That was up here under the Output tab. So place spot elevation, existing to. I can erase existing elevation labels if I want to start from scratch. I can change what layer those come in on and the size of those labels here. Other settings here are rotation angle, that sort of stuff, not really critical. Click apply, and now we're just going to pick some points. So I know that I'm going to be wanting to connect to this road someplace, so we should probably start getting an idea of what those elevations are. 940 over here, this side, the road's at 944. So we know, and we look at some low points on the site, look at 902, and we know the stream's going this way, and the outfall here is 883. So already we're getting some valuable information. It's very accurate based on the survey's data or the civil engineer's data. Let's look at it a little bit more objectively though. So we want to analyze this to figure out what is developable on site, what do we need to avoid to keep costs down. So let's look at slopes. There's a couple of ways to analyze slopes here in KeySCAPE. One is here in the surface modeling ribbon, analyze slopes. The other is in site analysis, and it's called the slope tool. Both of these achieve a similar output. The slope tool is more of a grid surface, and this one is more of a triangulated surface. And here in surface modeling, we can also get an accurate area takeoffs of amount of the different slope ranges. So let's analyze slopes. And it looks like I left my point command active. There it is. Sometimes those get sent to back if you forget to close them out. So let's analyze slopes. We want to analyze existing too. And we have a boundary we want to select, and we want to start thinking about what ranges matter to us for this design. And I want to display slope by percent slope. That's what makes the most sense to me. I'm going to generate slope ranges and have it do it automatically. So I want to go from 100% down to 0. I want 5 increments. This layer is fine for me. It's going to create a slope underscore 10 layer for me. And let's click OK. Whoops, I put these in backwards. Okay, so now I have a bunch of slope ranges, but I don't really care if something's 80 or 100% slope. So let's edit these a bit. So at the top end, we can group everything 25% plus. Let's double click on this and make this 25. And this is going to be a red color because that's kind of a no-go. Okay, sorry, because we need to start at the bottom here. So our first slope range is going to be 0 to say 5%. So 0, let's make 0 green for go. And we'll make this second one, instead of 20, we'll make it 5. And we'll make that green for go as well. Now after that, so from 5 to say maybe 12%, that might be more of a a yellow. It's like we're above handicap accessibility, but not really. It doesn't really mean we can't develop. It's not really expensive from a site development aspect. Actually, let's make this one 10, and we'll make it kind of an in-between green and yellow. Then we'll create another one. This one will be 15, and that will be yellow. Then we'll go up to, say, 20. This is getting pretty dicey, so we'll pick maybe an orange. 25 and up is going to be red. Okay. So we want to place triangles so we can see it on screen. Slope arrows are sometimes helpful. That's just going to place some indicators, perpendicular with the slope. You can erase existing slope analysis if you figure out that the ranges aren't appropriate for what you want to do. It's a great way to clear it out and start from scratch. But also generating a report is a good thing to do because that gives you an area takeoff of each range so you know the kind of the value of your site. So let's click apply. We'll select our boundary again. And we'll let that process for a moment. And as always, if anybody has any questions, feel free to type them in to the question box or the chat box, and I'll get to them as I go, and definitely by the end of the webinar. All right, let's not waste everybody's time waiting for this one to process. I'm going to quickly stop it from processing. And that's the challenge with surface modeling, is a lot of the times it takes a lot of resources depending on the size of the site. So you kind of have to manage, based on the performance of your machine, what you can handle. Let's go ahead and end the task here. And let's relaunch it. And we'll bring up that same file. I have another existing terrain already built in there, so we can start from that point. All right, let's open. All right, there's our drawing again. And we have that existing terrain already there. Once we finish loading, we'll jump back into the slope ranges. All right, surface modeling, slopes. Let's quickly just generate some slope ranges. Okay, and I already went through how we set these. We'll just stick with what we have for the moment. Let's generate the report and click apply. So now you see we're drawing our objects again, and here's the report generated. So these are the different area ranges, 0 to 11, 11, 22. It's kind of arbitrary, but you can see that we could have changed that. Let's put this report in CAD so we can save it, and we'll put it up here. Close. And now we can see exactly how much area we have developable based on our different regions. So this would be very helpful in a larger master planned community or a campus project or something where you're citing multiple structures, and it also could be used for some ecological planning, preserving steep slopes where stabilization might need to occur. You can also use this tool if you have a proposed grading plan and see if there's anything, say, above 5% that needs to be handicap accessible, and maybe it's not at this point. So a few different ways to use this tool. Let's look at one other analysis tool, and that would be on the site analysis tab here. Let's look at the aspect. This is kind of a neat tool because dealing with solar panels or solar gain, this could really help with siting a building as well. So we're going to use the existing model. Let's generate a legend as well. Let's look at what layer this is going to be on. And that's fine. You can change that to whatever you'd like. Let's change our text size to something we can read easily. So let's place this visualization on the surface model. Let's use solids. And here we can set different colors for different directions of slope. So north, northeast, all the cardinal compass positions, and you can change all the colors here as well. Click OK. And let's put the legend here and close. Now let's do some layer management here. I've got a few overlapping things showing. So I'm going to go in and turn off my slope analysis. Let's see here. That was under slope 10. There it is. Great. So now we have aspect determined. Here's the key. Again, these can be whatever you want. So we can see that our southern facing slopes are blue, which I probably would have made those red, indicating a little bit more solar gain. But this area here would probably be the warmest spot on site. And then up here we have past the crest of this ridge line, we have the shadiest spot on the site. So again, really quickly being able to analyze a site, looking at it objectively, make some design decisions early on in the process, maybe even before you win the project, just so you get a feel for what the site is capable of. Let's turn off these aspect layers as well. And let's look at a slightly different workflow. So let's say that we got our data from a point file, and that point file was just a series of dots. I may have some in this drawing here. No, I don't think that I do, but let's bring some in. I'm going to bring these in from a land XML file. Let's do a transfer, import land XML. Let's go find a file. I believe I have one. Somewhere here on my desktop. Maybe not. Anyway, so we brought in a land XML file. It's in here, it's just not visualized right now. And we want to create contours because that makes more sense to me as a designer, to look at contours and manipulate contours. So we can automatically generate contours based on a surface. So let's make intermediate and index. Let's use the existing data we have, and let's change some layer settings here. So I want my index contours on contour exist 2, and I want those to be, let's make them red so they're easy to see here. Intermediate, I'll put it on contour exist as well, and we'll make those a gray color. Settings here, again, we can set the contour interval. If we're on a flat site, we might want 1/2 foot or 1/4 foot contours. Here we have a decent amount of slope, so 1 foot and 5 foot makes a lot of sense. Click OK, click Apply. And so what it's doing here is looking for existing contours I might have had in the drawing. It's going to erase those because I may have made changes to this model. If this was a proposed model, I could have changed the elevation of a site or a drive or something like that. And so there it created these contours from scratch. They're virtually the same to the ones I had because that's how I created those original contours. Some other handy tools for dealing with contours have to do with annotation. So if we want to label them quickly, this is really handy for proposed contours as well. As long as they have a z-value, we can determine how to label things. So let's look at our annotation settings. Let's place them on the line. We're going to break the contour, and we're going to put an ellipse around it. So make these really fancy. And we're going to just label the index because it might get busy if we did every single one. And again, we can erase existing annotation if we want to start from scratch. So let's start up here on the top of this hill. We're just going to draw a crossing line where we want labels to appear. What it does is it creates the label, it cuts the contour, and redraws it. So very fast process. Let's look at, before we leave today, I want to just show a little bit of what's possible working with the proposed condition. So in this drawing, I've actually, I have a building, I have a site, done some development on that site already. Let me turn on my building outline, and let's turn on my proposed surface. So it looks kind of like a jumbled mess here, but let's look at it shaded and from an isometric viewpoint, and it'll make more sense. So we can see that I have a building I've popped into 3D. I have projected slopes away from that building down to the existing surface. And now that we have that data, I've also got a basin up here. You can see a little detention basin. We can see that this model is intersecting with the existing terrain. So down here we're in a fill condition, and up here we're at a cut condition. Let's generate contours for this proposed surface, and we can see that they're going to tie in to our existing contours. So let's go to P1, and let's make sure they're on an appropriate layer. So I got proposed, great. Hit apply. So this was all constructed using 3D polylines. So I would offset from the building, say 25 feet. We know that we need positive drainage away from the building, so that line was a few feet below, or 6 inches below the building footprint. Let me turn on the layers I just created. Proposed and proposed. And let's, yeah, that works. So we zoom in really closely here. we can see that we've matched with the tied into the existing terrain. We've got two surfaces overlap each other, and what that gives us is the power to calculate cut and fill. We can also quickly generate a grading plan, a construction plan from this geometry as well, because it all ties into the existing. Let's quickly look at the volumes here and see how close we are on cut and fill between the existing surface and P1. There's a bunch of options here, so we can look at compaction factors and other options, but let's just get a quick snapshot. So we need a lot of fill here. Need almost twice as much fill as you do cut for this project. So we might want to look at revising that finished floor elevation. Let's freeze off a few layers here to make it easier to see this proposed surface. And let's take away this building that's really just there for visualization to see how that I created this. I'm also going to turn on some of my construction lines. So some feature lines, projected objects. Let's see what else I can turn on here. And let's turn on, there we go. So we can see here, I created the cutout for the foundation. There's a slight batter to this wall, as there would be in real life, but it also helps with the generation of the surface because triangulated surfaces cannot be exactly vertical. So that helps get around that and accounts for that cut we need on site. Here's some contours that wrap around the site. Here again, we've created a bit of a retaining wall for a truck loading zone. And these weren't necessarily created with contours alone. They were created with actual 3D features. And we can get into how those 3D features are created in the next future webinar. But basically, under the layout tool, we have all these options here to project objects to a surface. We can do 3D offsets. We can assign elevations to polylines by vertice. Lots of ways to work here. And we'll get to that in a future setting. I don't see any questions popping up regarding, basics of creating surface modeling or looking at analysis tools. I'll quickly point out a few other analysis tools if you want to explore them on your own. So we had slopes here. We can also do flow lines. And really that just shows you where water is going to go on a site, helps you identify flat spots. So here, if I did a flow line on P1, hit apply, and let's pick a point there. Oh, well, I didn't like that point because I wasn't on the 10. Let me go back to the top view. Yeah, let's look at the flow line, P1, and say from a point here. So we can see that the water is going to go perpendicular to these contours, but then it's stopping here. So we need to pick it up with a catch basin or revise our grading to get it out of that spot so we don't end up with a pond. So it's great for analyzing existing and proposed surface models. The other two that people use a lot are the elevation. That's similar, workflow similar to the aspect in that you identify the elevation ranges that are most important to you, and oh, switch drawing is an accident. And then we get an output that has the areas annotated as well. So that's a brief overview. Thanks for joining, And if you have any questions, feel free to reach out, nate@keysoftSolutions.com. Be on the lookout. Next week, we're going to start our cycle over again. If you want a refresher on getting set up with KeySCAPE, the basics, setting units, setting standards, we'll go over that again. In the meantime, have a great week, and we'll talk soon. Thank you.